major quakes. These quakes are recorded in observatories such as this one at Berkeley, California. Recording is continuous. Time segments are marked at 1-minute intervals. Almost yearly, the seismograph records a very great earthquake. This is the case history of one major earthquake recorded at Berkeley on the 87th day of the year at 21 hours, 16 minutes, and 4 seconds. At Berkeley, the first waves to reach the seismograph are P waves, canal waves, which travel through the Earth. The arrival time of the P waves is documented. More data arrives. A second P wave reaches Berkeley from the earthquake, taking longer to arrive because it reflected off the Earth's surface and so traveled a greater distance. The longer the time interval between the arrival of the two P waves, the farther away is the earthquake. 4 minutes elapse between the two waves. The distance of the earthquake is approximately 11,000 kilometers. Data from a number of seismographs is inspected. The P waves arrive first at the station nearest the earthquake and continue to move across the network. A comparison of P wave arrival times discloses the direction of the earthquake. Calculations of distance and direction are used to determine the geographical location of the earthquake. The seismic waves originated in eastern Turkey, 10,800 kilometers from Berkeley. Possibly a disaster has occurred. Estimates of distance and direction provide no indication of the earthquake's magnitude, how much energy it released. A first estimate of magnitude is made from waves that come after the P waves. Since the magnification of the seismograph is known, actual ground motion at Berkeley can be calculated. Ground motion and distance are converted into a number on the Richter magnitude scale. Each unit on the scale represents a 10-fold increase in ground motion. In this case, the magnitude is 7.1, a major earthquake. Only investigators on the scene can determine the actual damage to life and property. Within hours, Turkish geologists begin to investigate what happened. In the mountains, where few people live, the only evidence of the earthquake is this rift in the ground. The rift is followed for miles, leading toward a populated valley. In the towns, where the population is dense, disaster has struck. For 10 seconds, the town of Geddes was violently shaken. Then the earth was still. Later, aftershocks added to the destruction. Survivors are ordered to evacuate, but hundreds did not survive. In Geddes alone, over 7,000 houses have been destroyed. An ancient mosque where generations worshipped collapsed. Of concrete, only a few years old, is torn apart. Its modern materials badly adapted to traditional designs. Beside the shattered mass of concrete, a lone young tree survives. Heavy tile roofs have broken and crumbled, burying the people inside. Stronger walls and lighter roofs would have saved many houses and many lives. Some who escaped from their homes met death in narrow streets when walls and roofs collapsed. The survivors wander aimlessly, stunned, homeless.
Ahmet, Hüseyin, Kasım'a. Hemen sıhhat ekiplerinin kurduğu...
Overwhelmed by catastrophe. Some surrounding villages have been totally destroyed. In this town, the only structure still standing is a concrete pillar. Ironically, the pillar supports a bust of Kemal Ataturk, the founder of modern Turkey. To the people who live here, this disaster seems total, but it has happened before, and it could happen again. This region of Turkey has experienced a number of damaging earthquakes during the past century. It is located near a fault in the Earth's crust. Deep in the Earth, stresses increase between large masses of rock. To relieve this stress, the rock masses suddenly shifted along the fault. The shock produced by this movement is felt on the surface as an earthquake. The survivors of Geddes are returning. The basic necessities of life have become urgent problems. Only emergency measures can meet them. Food, contributed by many nations, is trucked in and distributed. Hunger must be relieved to prevent panic, disease, and starvation. To relieve immediate suffering, emergency planning is imperative in an earthquake zone. Food is only a first step in survival. Orphaned children, people with nowhere to go, all must be helped. Electric power and water supplies have been destroyed. The people use polluted streams for washing, for cooking, for drinking. Adding to the pollution, they increase the danger of disease. As the people of Geddes struggle to rebuild their lives, the geologists at the scene continue their investigations. The data they have gathered from the ruptured land, from devastated towns and villages, and from the people themselves, raise questions about how people live in areas where earthquakes strike. Would there have been less damage to life and property if different materials had been used? Would modern engineering have saved more buildings and more lives?
Şimdiye tahaccübe mahal vermeden en çabuk bir şekilde evlerinizi terk edin ve açık sahalara koşun. Evler arasından geçerken duvarlara dikkat edin.
11 months after the destruction of Geddes, a less intense earthquake strikes in California. Its magnitude, 6.5 on the Richter scale. In this modern hospital, built to withstand the vibration of a major earthquake, only a few lives were lost. But because of permanent movement of the ground under the building, the structure is a total loss. Portions of the vital highway system are reduced to rubble, seriously interfering with access to the disaster area. Railroad tracks buckled with the intense ground motion. Utilities designed to be earthquake resistant tumbled. The complex systems of modern urban society are increasingly vulnerable to the forces of nature. Frame buildings with heavy roofs perform poorly, just as in Geddes. Rescue efforts are put into operation immediately. But for many, they come too late. The devastation in Turkey and California show the importance of good pre-earthquake planning in active seismic regions of the world. What will be the lesson of these disasters?